Hello everyone, welcome back. Let's continue with the lectures. Today's lecture is about flow control in C, which is the F structure. Before we start talking about it, let's look at algorithms. The fundamental step of your course is to understand algorithms. So what is an algorithm? A program is actually an algorithm. The program that you write is actually an algorithm. But any program, as I said, is a set of commands that tell the program what to do. Okay, this sequence of commands, the way you state it sequentially, one statement after the other, how you want the flow to go, this is called an algorithm. So let's read the definition. It's a sequence of finite number of steps arranged in a specific logical order, which when executed produces the solution of your problem. So that's what we're talking about throughout the course, which is we take an input, we do some computations in a certain order, in a certain sequence. The sequence is very important, how you're going to actually perform these statements, and then you get the solution of the problem. So an algorithm must specify these requirements. It may have an input. It could have an input. It might not have an input. Depends what you're doing. Okay, sometimes you just print F stars. You didn't have an input at that point. You can have any program, whatever you want. It must have an output. You should have actually a result. It has to do something. Okay, and it should not be ambiguous, which means that every step, as I told you in class, you are dealing with a dumb machine. We say it's smart. We make it smart with our programs, but it's a dumb machine. Every step should be clear. So ambiguous is the opposite of clear. Every step should be deterministic and clear. There should not be different interpretations to it. It has to do one thing. It has to be exactly do one thing. So every step in an algorithm must be clear and do what it's supposed to do. As most of the important knowledge that we have today, algorithms stems in Arab's knowledge, which is Khwarizmi. Okay, Muhammad ibn Musa al-Khwarizmi. He's the one بيسمون خوارزميات. The algorithms are called Khwarizmiyat in response to the Khwarizmi, which is an Iraqi, I suppose, yes, from Baghdad, an Iraqi scientist who actually created this very long time ago, the algorithm. So what's an algorithm? An algorithm is a procedure in terms of actions to be executed and the order in which these actions are to be executed, which means the order is you just don't put things up and down. There has to be a sequence of events, a sequence of commands that have to be executed in a certain way in order to solve a certain problem. So an algorithm is not a computer program, but rather a clear description of the program. So when algorithms were first introduced, okay, there were no computers, but the algorithm is the steps that the program follows in order to solve a problem. Okay, so the algorithm, when you write an algorithm, yeah, then you implement it into a program. These steps are implemented in C. They could be implemented in Java. But the algorithm itself is actually every step that is going to be done in the order in which is going to be executed. Okay, so this is the algorithm. The implementation, we call it implementation, is when you write these steps in a certain programming language to make a program. Something similar to this, which I like to give it as an example, is a food recipe, which means that let's say you want to do a pizza. What do you need for a pizza? So the input for the pizza is butter, sugar, eggs, all-purpose flour, baking powder, salt. So what are we doing here? A pizza brownie here. So it's not a real pizza, it's a pizza brownie. So all of these are the ingredients. The ingredients is the input to, so what are the inputs? The inputs are the ingredients. What are the steps? The steps is the algorithm, how it's going to be done. Can you put it in the oven before you actually do the dough? No. So there has to be, it has to follow certain steps in order to get the output. What would be the output? The cooked pizza, right? So do you put the pan in the oven and turn it on before you actually do the dough and you put the things on it? No, of course not, right? So it has to follow a certain step. And this is the recipe. The recipe, this whole thing over here that you see on the slide is the algorithm. When you actually start cooking it, that's actually the program. So implement it. How many times can I do this algorithm? How many times? Many times. So you implement it in a programming language. So this is the recipe. I do, if I have the recipe, when I do it actually in real life, that's the program. Let's say you implement it. You can have different implementations. So algorithms are either described in pseudocode or using graphs and flowcharts. So the algorithms, so when I say algorithms, is actually the steps that the program should follow in order to solve a problem, the steps and the order in which they should follow, okay, in order to solve the problem. The algorithms are written in, so you don't write an algorithm in C or C++. You write it in English language, okay, or in a flowchart, and then you have to put it, once you do the algorithm, that's 95% of the work, and then you will write them in C, the syntax of C, of C++, of any other language, okay. So pseudocode is a language which is English and math, which helps me actually write the algorithm. It's similar to everyday English. It's not actually, it's for human beings, okay? It helps you to think out the program. So this is how the program is going to look like. So you don't just start writing code. You have to think out the program, put the steps, and then it will be very easy to convert into a C program. You just convert every statement to the C program. So flowcharts is a way of writing this code, okay? It's a way of writing, sorry, the algorithm. So it's a graphical representation of an algorithm drawn using certain special purpose symbols connected by arrows called flow lines. This is the flow line, how the computer is going to flow from one step to another, okay. There's always a center entry and a single exit. It always has a star, a circle. This is that could be, this is the entry, this is the single point, that's the entry to the program, and this is the exit. It should start at a point and end at a point, and it has certain structures. Every statement is put in a rectangle, okay, and it's connected with flow charts, well, with flow arrows. Why? Because you should show the one who is reading the algorithm or the flow chart, okay, how it's going to proceed this way. So you have to tell him the direction of how to proceed, the flow. So you connect from one step to another. It makes programs easy to build. So so you either write a flowchart or a verbal pseudocode. Instead of writing the steps in English, you can write them simply using a flowchart like this one. Okay. Now that we talked about flowcharts and we talked about algorithm, now it's going to get into your mind. Why are we talking so much about flows? How it's going to flow, and the order in which the sentences are going to be executed? This is because we're going to talk in this lecture about the control structures. Control structures controls how the statements are going to be executed. So far, in the programs that I was writing in class and the ones that you saw in these lectures, what happened? So far, they all had to be executed sequentially. And the statement that appears first should be executed first, one by one, one by one. Okay? So sequentially, statements executed one after the other in the same order, in the order they are written. So the program will not go execute the last statement before the first statement. No, it executes one statement after the other as it sees them in the program. Okay? So this is how normally, so far, how our program was executing. If you have integer x first, then integer x is done first. Scanf is done second, okay, sequentially. An alternative way is selectively. We can have selective. This is the first time we see selective, which is branching, which is making a choice. So this is the if structure, for example. If structure is one of the selection structures. We have if and switch. We have two selection structures in C, which is if and switch, which we will talk about them at this point. Okay, so selective structures. You select if a certain value is positive, go this way. If a value is negative, go the other way. So in here, we're adding more flexibility to your program. In addition to selective structures, which is if and the switch statements, you also have repetitive structure or iterative structures, which means that I want to do this piece of code from here to here 5 times, then it will repeat it exactly 5 times. So these are we only have these structures which you will learn. Mostly when you finish this, we would have learned, let's say 90% of 80% of the course when you finish repetitive structures. So you can either have sequential structures, which no structures so far, the way we were working so far. Selective is if or switch. Repetitive, a certain piece of code which is going to be repeated. This is the for and the while, which we will see these loops after we finish with the selective structures. So at this point of the course, we'll study the selective structures and then we'll study the repetitive structure. So selective structure is saying that some statements are going to be executed if a certain condition is true. If it's true, then it will be executed. Okay, so we're adding more flexibility to the code. A condition, how is it this condition? It's a yes or no question. Is it, if yes, okay. If no, then don't execute it. That's yes is the true and no is the false. We refer to yes is the true and no as the false. A condition is met, and the condition is true if it evaluates to true, and if it's correct. All right. So let's look at more some symbols of the flowchart. I don't know why this thing is showing. Okay, so flowchart symbols. You have input. If you have an input, you will have it as a parallelogram pipe. So a parallelogram. So a parallelogram, okay, it stands for an input. Well, actually, we're not picky about that. So you can have the input as a rectangle as well. So either a parallelogram or a rectangle. Okay, so if you have an input, so I'm getting an input from the user or an output, then it's a parallelogram. In the exam, you can have it as a rectangle, that's fine. But to be more correct, a parallelogram is input from the keyboard or output on the screen. So read, when you say read, يعني input, print, يعني output, okay? Any calculations, any computations, pi r squared, this is going, we can put it in a rectangle, okay? So this is what we have done so far. We get an input. We can have another rectangle here to declare our variables. You input them, okay? You do calculations and then you print them. That's what we have done so far. We have covered until this part. If I have these here, it's very easy to put each of those structures into a C statement, right? Now, what we want to learn now is the if. This is the if structure. It has to be a rumpus. So this rumpus here is a yes or no question. Is radius less than 0? If the radius was less than 0, okay, then I cannot do the thing, right? So if the radius is less than 0, okay, if the yes, then do something, if the no, do something else, okay? And there's always a start button and a stop, a start circle and a stop circle. Let's see them in a real flowchart. So this is a sequence. If you want to execute sequentially, this is what we were doing so far. Define an integer, declare an integer, input an integer, calculate on an integer, output an integer. So the program would flow sequentially. Selectively, this is the expression, is x greater than 0, is a true, do this one, and then it will exit. So it either goes in a selection statement. Please pay attention now. If I lost you, please pay attention again. Okay, and no phones are allowed. No WhatsApp in class, so no WhatsApp here too. All right, so let's say I have a selection structure here. So if it's true, then, so this is very important really. If it's true, then I'm going, the program will execute this way and go. It cannot do both. It will do one of the branches. So if it's true, it will go this way, branch out. If it's false, it will go the other way and exit. Okay, it cannot do both. The repetition structure is like the if. So if it's true, it will do this statement, but not only once. The expression is true. I will repeat and repeat and repeat until this condition becomes false. When it becomes false, I will exit. So again, the repetition structure, the same as if, but instead of executing it and going out, like this one, execute it and repeat and repeat. As you can see, the flow of the arrows go back to the condition as long. So how would I repeat? As long as the condition is true. So as long as the condition is true, repeat, repeat, repeat. Okay. When it becomes false, that's why after the statement, where do I go? I don't exit. Instead of exiting like this in an if structure, in a repetition structure, go back to the condition and repeat, repeat as long as it's true. So for now, for the coming lectures, we're going to work in this structure, and then we'll start with this structure and see. It's a full chart of a program with sequential statements only. So only sequential. This is what we have seen so far. So start, end, start main, stop main, read time. You can declare here variables, read time and input time, calculate the velocity, calculate the acceleration, print the velocity, print the acceleration, stop main. Okay. So this is now the selection. If denominator is less than 0.0001, we know that we cannot divide by 0, it's impossible. So to avoid this, if denominator is less than, say, 0, if yes, print denominator is close to 0 and do what? Exit. Print and exit. You don't do this part. You only do the yes part. If the condition was false, then you know the answer is no. Is denominator less than 0? No. Then okay, now I can get the fraction and print the fraction and go. So either this way or this way. In this case, this is a repetition structure. Okay. So is time equal to 0? Is time less than or equal to 0? If it's yes, compute velocity, print velocity, increment time. Is less than or equal to 10. Increment time. So if time was 0, increment time, it will become 1. And then how do you go? Do I exit here? No, there's no connection to the end. It's connected back to the condition. So the statement that you should keep in mind, or write it on your notebooks, as long as the condition is true, I'm going to repeat. So after you finish the structure, okay, the body of the structure, you go back to the condition. Is it still true? If it's true, compute velocity, print velocity, increment. It's 2 now. 3, 4, 5, 6, 7, 8, 9, 10. On 10, is it going to be true? Is 10 less or equal to 10? Correct. Yes, 10 is less or equal to 10. So I do it. Increment by 1, it will become 11. Let's go repeat. Is time less than or equal to 10? No. So what do? No, I exit. Okay. If I didn't have this block, what would have happened? Can somebody answer me without me hearing him? But that's okay. If I don't have increment time by 1, what will happen? It will loop forever. It will never, the condition here will never be false. It will always loop forever. That's called an infinite loop, and that's what we avoid. Okay? We'll talk about this after we finish if and switch structure. So the if selection structure, so it's used to choose among alternative actions or alternative paths. You have to choose one of the paths, okay? In pseudocode, if student's grade is greater than or equal to 60, then print pass. So you're only going to print pass if this was true, which is if the grade is greater than or equal to 60. Okay, if it's false, the print is ignored and the program continues. Okay, so this is an if only structure. So this is only if. We can have, because I said that, you should conclude that there is also an else. So if it's true, do this. If it's false, do another thing. This is the if structure. So if grade greater or equal to 60, print passed. Okay, that's how it looks like. Okay, now true or false. So this is if grade. This is how you go. How the pseudocode would look like. Okay, if grade greater or equal to 60, printf passed. Or this is also how it looks like in C. Okay, so let's see. We're comparing two numbers using only if, no else here. So else would be if is again true. Do this. We don't have an else here. We only have an if. Okay, so I have two integers, number 1 and number 2. Enter two integers. I input them from user using scanf. Okay, if number 1 is greater than or equal number 2, then I'm going to say number 1 %d is greater than or equal to number 2 %d. So substitute number 2 in %d, number 1 in %d here. Okay, so as if I'm saying that number 1 is greater than or equal to number 2. If number 1 is less than number 2, okay, then I'm going to say number 1, the value that I have entered here, is less than this number. Okay, so this is an if structure. One of them is going to be true. A number cannot be true in both of these, right? These two numbers. One of them is going to be true. Because I have if, I also have if else. So else is the body of else is going to be computed if the condition was false. So if student's grade is greater than or equal to 60, print passed, else print failed. And this is how the flowchart looks like. So if grade is greater than or equal to 60, print passed, else print failed. So we're going to have either this one, this path, or this path. If there's no else, then this would be just connected. If it's false, just connected to the next statement. Okay. So this is a C code. If grade greater than or equal to 60, print F passed, else print F failed. Okay. So this is F else. As you can see, you can have the body of F, so the part of the code that's going to be executed. If the condition was true, is this part. Else, so if the condition was false, this is going to compute. A common mistake is that they put a condition here. Else doesn't have a condition. Else is also always the opposite of this condition. Else never has a condition. Else is the opposite of the if condition, which in this case would be is that if grade greater or equal to 60, then the else is grade less than 60. So comparing two numbers, okay, so if number 1 is greater than or equal number 2, then we're going to say number 1, substitute number 1 in percent D is greater than or equal to number 2. Else, instead of having two ifs, what do I put here? Else print F, number 1 is less than number 2. Okay? Alright, so the if body is enclosed between two braces and the else body is enclosed between two braces. There's no semicolon in the if structure. If you had a semicolon here, this means that the body has ended. So in the exam, this is a trick. For example, if I put a semicolon here, then if number 1 is greater than or equal number 2, do nothing. Okay, so if you see there's a semicolon beside the if, okay, this is a common trick that we use in exams. If there's a semicolon, this means the body is empty and you cannot put an else. Yeah, okay. So if there's a semicolon, this means the body is empty. Alright, so here you have if else, you can put them as if, okay? So we can split the following statement into two separate if statements. If x greater than y, temp equal x, else temp equal y. I could have put it as if x greater than y, temp equal x, if x less than or equal y, temp equal y. This is equivalent to this because else here, so else is like the if of the opposite condition. Okay, this is very important. So this is the flowchart of the previous slide. So this is an if else, if true, temp equal x, else temp equal y. Then this is done as two ifs. Okay, so usually this one is simpler. We choose this one. So that's the same slide. Please pause and take a look at it. Very simple. And when the structure ends, continue with the next structure, whatever statements you have. It's a common question students ask me. So if fills it, if it ends, you can do whatever you have statements. You can have as many statements as you want in here. More statements after each other. Okay, we end when we end. When we reach the end of main, that's where we end. An important thing is the nested if-else structure. The nested if-else structure used to test many situations by using the if-else structure inside each other. So you can have if inside an if. Okay, so let's say here if number 1 is greater than number 2, print number 1 is greater than number 2. Else, you can have another if inside else. So in the body of else, there's another if. If number 1 is equal to number 2, print f number 1 is equal to number 2. Else, print number 1 is smaller than number 2. One tip about the nested structure, what I like to give to my students, is that each else refers to the if just above of it. Okay, so this else refers to this if. This is the nested structure, and that's how a nested structure flowchart looks like. So this is all the else body, and in the else body, I can write anything, any code. Okay, so if it's true, print number 1 greater than number 2, continue. False, another, this is the body of false. I can have anything. This is the body of else, or false. There's another if, that's okay. If it's true, print number 1 equal number 2, else, that's an F, false, else, print number 1 less than number 2. And this is its code, not so complicated. If number 1 is greater than number 2, printf number 1 is greater than number 2. So we'll set the body of f finished. So the body is put between braces. So the body is like actually the borders of this rectangle. So it starts here and see that's the body of f. Else, this is the body of else. Okay, we do some indentation to show you how it looks like inside else. So where's the body of else again? The of else is this. It's enclosed between these two braces. Whenever you open one, you have to make sure you close it. If number 1 is equal to number 2, this is the body. This is the body of f. That's, okay. This else is for the f previous to it, and this is the body of this else, and this is the closing of this else. So this is the body of this else. The body of this f is actually in here. Okay, this is the end of main. We're saying here you can write an easier way. So what's the difference between this one and this one? Can you take a look, please, before I tell you? So else here, I can put this if immediately beside else. Here it is, immediately beside else. Else if, okay? Same thing, all right? But I didn't have to put the body of this else, as you can see. I omitted these, sorry. I omitted these braces. You don't have to put them, okay? I removed here. Very simple stuff. Please pause and write them on your phones and run them. It's very important. It helps you to follow up. Okay. This is another example of a nested if structure. Okay, so if students grade, this is the pseudocode, of course, is greater than or equal to 90, then print A, print congratulations. Else, if it's not greater than 90, then it's less than, also greater than or equal 90. If it's not, else, what's else? Again, else is the opposite of greater than or equal, which means it's what? Strictly less than 90. If it's strictly less else, strictly less than 90. Okay, I would check if student nested if student's grade is greater than or equal to 80, then he's a B. Else for this if is the opposite. What's the opposite of greater than or equal to 80? And I'm sure he's less than 80. So if he's less than 80, okay, so less than 80. So else means he's less than 80. I will check if it's greater than or equal to 70, then he's definitely a C. Okay, the opposite of, so this else is for this F. Opposite of greater than or equal to 70 is less than 70. So if he's less than 70, okay, so if he's less than 70, I would check if he's greater than or equal to 60, then he's a D. What's the opposite of greater than or equal to 60? Less than 60, then he's an F. Okay. And this is the code of the source code of C. As you can see, if let's check it out together. So if greater or equal to 90, this is the body of if. This else is for this if. Okay, the body of else is this one here. That's the body of else. If you don't have to put these, by the way, you don't have to put this brackets because it's an F. So if greater than or equal to 80, print F, he's a B. This else is for the F, which means he's less than 80. Another F here, that's the body of F, he's a C. Else for this F, then he's less than 70. I check if he's greater than 60, then he's a D. Else for this F, then he's less than 60. And then the body, this is the body of else, which is F, and he has lost. Okay, and this is a more readable one, which means what we did in this one is that instead of putting braces for each else, okay, we remove the braces and okay, the corresponding closing brace, and we put this if beside the else. That's what we did here. And make sure you have a space, okay? You should put a space. Let me highlight this so that you pay attention. You should have a space, okay? same thing. But أكيد هون you still need to put the braces, okay? Because it's more than one line. Usually, if it's more than one line, you should put the braces. Okay, that's another example on nested if else. So if x greater than y, then if y less than z, k plus plus. Else, so by now you should be able to do the mapping. This else is for this if. So when we got to this if, I'm sure that x is greater than y, okay, y less than z, then k plus plus. Else, yani y is less or equal to z. So if you get here, then y is less or equal to z. Y is less or equal to z, and at the same time, but it's inside the if body. So this is the body of if. So it's also x also is greater than y. In this case, what do? In this case, I do m plus plus. This else is for this if. So this is true because x, so this means that x, the opposite of greater than y, is less than or equal to y. Okay? So this else is for this if. This is خلاص. This one ended. So this else is for this if. Okay? So this is the pseudocode. Can we erase this thing? An eraser. Okay, so this is the nested if structure. If, this is the body of if, else, and then else. على طول, the braces is for the body. Okay. By the way, in this structure you can remove all the braces, and I put them colored so that you can see the beginning and the end of each brace, each body. So this is x greater than y. True, false. Okay, so if it's true, I'm going to do this part. Okay, it's a very nice animation. If it's false, then I'm going to do this part. And else, you can do this part. Okay, and then they connect and follow with whatever you have in your program. Okay, and in this part, you have another if, that's a nested if in yellow. Okay, true or false. If it's true, then k plus plus. If it's false, then m plus plus. Very clearly, you connect them and you connect with whatever steps you have. All right. This is an exercise. You can pause it and get the results and check if they are true. So, and please write them on your phones and check the results. Okay. So do them computation on the paper and then write them on the phone and run them to check their correctness. Find the value of a at the end of this. This is an example. You can see such a thing in an exam. Okay, so you have to implement it. This is how it looks like. Please pause and look at each step, just as we described. Okay, take a look at it. Use the color code for the if body, else body. We have a nested if here. If and the if body, what do I have? I have an if and an else. Okay, so this is the if body. The true here is the if body. Inside the if, I have an if, a true and a false, a true and a false, and in the else, I have another if. This is the else here corresponding to this one. Okay, you can write it down and check the value afterwards. In here, what did we do? What's the difference between this code and this code? We have removed all the braces. So basically, you put the braces so that you don't get mixed up. You put the braces only when you have more than one statement. Okay. We removed all the other braces. That's how it looks like. The same thing. Okay. Now in the condition, you can have equal equals checks if a number equal to another number. You cannot put one equal. If you put one equal, it will always be true. Please keep it in mind. This is a very important thing. You can write it on your copybooks. If you have one equal sign, then it's always true. If x equal 1 equal to y, then it's always true. You have to put 2 equals to be a question mark. This is if x is x not equal to y, is x greater than y, is x greater or equal to y, is x less than y, and if x is x less than or equal to y. Okay, I will stop right here and we'll continue with logical operators next time.